Hi, folks. This is Dan Forrester. We're going into week 2 of geometric optics, and part of your discussion question has to do with fiber optic cables and their properties. And so I thought I would provide you with the Nobel Prize lecture of Professor Cow, who well, he won the prize for inventing fiber optics. Now, notably, it was an entire team, and his prize he represented his entire team, and that's the nature of these collaborations. That somebody gets the credit for all that stuff. Okay, even though there are probably hundreds of people working on it. But fiber optics and the purity that's involved, and so on and so forth, that's an ongoing field of research. And I mentioned one in the text here. And okay, so we know that the fiber optic cable is, we think of it as a long cylinder with a higher index of refraction and the air outside having a lower index of refraction. So you could get a total internal reflection going. Um, but if we were to model this as a successive layers of smaller and less and less, smaller and smaller indexes of refraction, we would notice that there's a tendency to bend the path of the light back toward the center of the fiber. And that would possibly increase the distance that you could transmit a fiber optic signal without a repeater. And when we're talking about trying to transmit fiber optic signals across, say, ocean beds, oceanic cables, that would be very, very useful. And so, like I said, it's a field of ongoing research and something you might want to mention or look into. Okay, I'll let you go now.